Hello, students, friends, colleagues, C++ learners, and YouTube uh, world. This is Dr. Satish Singhal, PhD from Computer Information Technology Department of Rose State College in Oklahoma City, Oklahoma. Today I'm going to talk about C++ nested classes. Nested classes are classes that are defined inside an enclosing class or outer class. And there are 6 different ways you could do them. It will be a monumental task to really give examples of all 6, but I'll give the example of one of the most important ones. As you know, inside C++ class, you could have a private area or a public area or a protected area, and you can either do the full definition of a function or a class inside the class itself, or you can give the implementation detail outside and only the name inside. So I'm going to show you the 6 scenarios possible, and I'll discuss only one of them at the end. So here is my class called outer class, and here's the private area. So I have here class inner1, but just the name only, not the full definition, in the private area. And then I have class inner2 in the name, as well as the full definition will be inside. So where's the definition of class inner1? That will be later outside here somewhere. So here somewhere I'll say, and I'll need the scope resolution for that. So it will not instantiate without the outer class. So here I'll have to say outer : inner 1 and the full definition here. Okay. So even though it's in private area, still in this global space in the implementation file you can still do that. Okay. Then this one is defined, all of it, name and full definition inside. Same thing for the protected. I have a class which is in name only. Its full definition will be outside, but inner4 full definition and the name is inside. So inner3 will be defined here. Again, you need this scope resolution. Okay, no semicolon here. It will be defined like this. So you'll have data members and functions here. Then inner4 is completely defined inside in the protected area. Inner5 again is name only in the public area, but full definition will be outside. Inner6 is in the public area, but fully defined inside the class. So inner5 will be just like this one. So in fact, I'm just going to copy and paste this one. Make it inner5. And then full definition here. Okay, this is a dizzying array of changes and choices, so to speak. I'm only going to talk about this case, one of the 6 cases, because some of the iterators are written that way. So let's go to Xcode and show you this case only. So in Xcode, I have a class called person, Hopefully you can see it. And inside that I have a private data member that belongs only to the person class, the name of the person. Then in the public area I have a nested class called address, and it has its own private data member. Number means the street number, or house number or something. Then I have the street address, then I have the state and the zip code. And since this is last case, case 6, I'm going to define everything for this class inside this class. So I have a constructor for address which takes the default argument for all cases, which means street number is set to 0, default value of street is street not set, default value of state is state not set, default value of zip code is zip not set, and then I'm using the initialization list to initialize all the members. I'm not doing any validation here. Abs is written so that in case by mistake they entered a negative number, we just change it to positive number. And the class address has a toString function, so we can print all the data member using the toString, and it just does the return address. ToString function, this is in new C++11. If you pass in an integer, it will return a string containing that number. Okay. This is a literal. No, this is not a literal. Just whatever is stored in the street variable, that's going to show up here. Whatever is stored in the state variable is going to show up here. What is stored in the zip code variable is going to show up here. So basically, toString will just print the contents of the address class. Okay, now I do want to include address as a data member, an instance of address as a data member inside the address class, inside this person class. Okay. Well, there's a problem if I include it here because address has not been defined yet. So if I include here, I'm going to get this compiler which says unknown type name address. So even C++11 is not smart enough to jump ahead and figure out that address is a class. So I cannot define it here. But once address class has been defined, I can go back and make another private area and define address type, which is address class, called paddress here. Here it's okay because it has already been defined. And of course, you can rearrange your code in a way that you have a public sections here and address class is totally defined here in that public section. Then you have private area for the person class and so on. I mean, that's not a problem actually. That's perfectly okay. All right. Then this was the public area for, so since I'm done with the address class, I'm going to fold it. So in the public area of person class itself, then I have a constructor. And there again, I have the initialization list, name not set. Notice address type is defined here, so I can use it now. And for its default value, I just call the default constructor of the address class. And there is a default constructor because we folded default and explicit into one. Both classes have default and explicit constructor because we folded that into one. Okay. But if explicit value of name and address are given, then we use this initialization list to initialize both of them actually. Okay. So body does not need any code because I'm not doing any validation. And then I have the toString for the person class, and which says return person name. So name member is printed. And since my address class if I look at it, already had a toString function. I can just call that to print the P address member, this member here. Okay. So understand, for the same class in C++, you can write data members and functions in any order you like, but the type has to be defined before it's used. Okay, so that's the detail. And once again, if you want to see the code, I'll undo all the code. I'll show all the code. Possibly not all of it, maybe. Let's try to get the full screen view. Let's try to remove that too. So really, I think you can almost see. Okay, I can make it a little bit easier for you. Lesser lines of code. And yeah, I do want to fold it into one page so you can see the entire code. And let's do that here too. Okay, so now you are able to see entire class and its nested class together. I'll just pause it here for a second so you can see all of the code. But you feel free to pause video also so that you can see all of the code. And those who are in the YouTube land, you can take a screenshot right now. Pause the video, take a screenshot, so that way you'll have the code with you. Okay, pausing is finished, and you can pause the video more if you like to see it in more detail, and take a screenshot as well. All right, now I'm going to show you how I used it. So for that I need the bottom area. So I'm going to open the main function. So notice here I create an object of person P1 type. I give the name, but I call the default constructor of the address class. And notice, since address is contained inside the person, it's not visible without this scope resolution. So what I'm saying here is that in person class, call the default constructor of the address class. In fact, in this case, you don't really even need an object. But if default constructor is set, call for the address class, then street address number will be set to 0, street not set, state not set, zip code not set. All those are going to show up. So I'm going to run the code now. Actually, let's comment out this one so we can see the printout. So I create the P1 object with the name John Doe, default constructor of the address class, and then I print whatever is built. And I run it, and it says build succeeded, and I'm not sure whether fonts are small or large. I will just copy and paste that here. So really it prints this person name John Doe, which it should, but remember we call the default constructor, so it prints address 0. Okay. Yeah, default constructor of the address class. Street not set. Street not set. State not set. State not set. Zip not set. Zip not set. Okay. So we do that, and let's undo this. All right. So that's that. Now I'm going to comment out this line, and this line don't want to see it anymore. Then I have the person P2, where everything is explicitly defined. Name is defined Mary Doe. So that's the name member of the person class. That's Merido. So this time we call the explicit constructor the address class, but we don't create an address type object. So we call the explicit constructor of the address class. So which code will be executed when we do that? Well, exactly this code will be executed. So default values will not be taken this time because we have a explicit value for address, which is 3200. We have explicit value for street, which is Pico Boulevard. We have explicit value for state, which is California. And we have explicit value for zip, which is 90405. But we didn't create a person address object. But this will do the job. So let's run this one. So it should really Merido 3200 Pico Boulevard, California 90405. It should print that. And actually it does. So if I can copy and paste that for you right here. So it does print that Merido and then address 3200 Pico Boulevard, California 90405. Those are the argument passed to the no name address object. Okay, this is perfectly okay. All right, undo this one. Now, third scenario I want to show you is that we do create separate objects for each one, the person and the address classes. But since address is passed to the person, we have to create that one first. So that's the access mechanism for this inner class called address inside the person class. So we create an object of that, ADRS, and we pass the value for the street number, street name, state, and the zip code. And then we create person3 object, P3, where we pass the name and the address object so that we can execute this constructor of the person class. Okay. So when I print P3 toString, I should get Tim Jones and this whole address. Let's do that. And also I'm printing the address alone, so that's why I get this output here. So let's go below this. So first two lines are printed by P3 toString. It has a name and address was passed as a argument. But last line comes only because we were able to print the ADRS object as well. Okay. So really that's it. I just wanted to show only that much. And basically you can see that when a class is defined in the public section, you could create an object of that. Of course, you have to use the scope resolution. Without that, C++ would not know which object you're talking about. Using scope resolution gives us access to this inner class defined inside the person class. Okay, and then if there were any other function in the address class, those could be called also. And important thing is that data member for an inner class, nested class, can only be defined after the nested class itself has been defined. We will use this technology we just described to describe iterator class in a self-designed list class, for example. And once again, thank you so much for watching. This is Dr. Satish Singhal, PhD, and we just talked about C++ nested class, at least one important case. There are 5 other cases. If I find good examples of those, I mean, from the sake of argument, like presentation, I can do them, but really it's best to see some examples that are applicable in real software engineering. Thanks so much. Bye.